Thunderstorms carry an arsenal of dangerous weapons, and many of them can strike with little or no warning. Much has been learned about severe weather in just the last few years, but much is still unknown. We know what a thunderstorm can do, but when? Where? The answers to these questions can rarely be predicted with accuracy. Any advances in tornado and thunderstorm forecasting will probably come from here, the National Severe Storms Laboratory in Norman, Oklahoma, NESSL as it's affectionately known. Now, it may not look terribly impressive to the casual observer, but to storm researchers, all roads lead to Norman. One of the most promising new tools to come from NSSL is Doppler Radar. With Doppler, a trained forecaster can look inside a thunderstorm cloud and actually see a tornado forming as much as 25 minutes before it hits the ground.
A conventional radar sends out a signal, and just a fraction of the energy bounces off of precipitation. Raindrops, hailstones, comes back to a receiver, and it stops there. A Doppler radar, it starts with that same signal, bounces it off of the precipitation, but when it comes back, not only does it measure the amplitude of return power, but in addition, it measures a slight frequency shift that occurred when the energy bounced off the raindrops. And that frequency shift gives you the motion of the raindrops. Knowing that, we see then the rotation up inside the cloud.
But even with high-tech Doppler radar, someone in the field has to be there to prove that what the Doppler says is happening in the storm really is. Chase teams provide the eyewitness accounts, like this one headed by Howard Bluestein of Oklahoma University.
When we're there at the storm, we can say, yes, there is one, or no, there isn't one. Yes, there is large hail, or no, there isn't large hail. There may be small hail or no hail at all. Another very important purpose of the Severe Storm Intercept project, which is becoming more and more apparent in recent years, is that we're able to make direct meteorological measurements in the vicinity of severe thunderstorms and tornadoes. We're able to make measurements of pressure and temperature and wind in the vicinity of these storms. We're able to release weather balloons in the vicinity of these storms to learn more about what actually causes these storms to form in the first place.
Chase teams make those direct measurements with a device they call Toto.
Deploy Toto right here, Steve.
The idea is to leave Toto in what they hope will be the path of the tornado. They've been successful only a handful of times, but even so, Toto has revealed some important new information about tornadoes.
We have learned with Toto, for example, that the pressure drops in the vicinity of tornadoes, of some tornadoes, is not as large as had been expected earlier. We have also learned with the balloons that the depth of the relatively humid air right where the storms form is a lot greater than it is elsewhere.
The development of Doppler radar has led to more new forecasting tools. If you point Doppler radar vertically, you have wind profilers. They sample wind speed and direction at different heights almost continuously. Until recently, such measurements were taken only by weather balloons about every 6 hours. The wind profiler means better information, more information, and improved forecasts. LiDAR Doppler is another application of the same basic technology. LiDAR uses radiation frequencies close to that of visible light. It's used to see wind patterns in clear air, the kind of patterns that can be very dangerous for aircraft. With all this new information, thank goodness for computers. These computers, known as AWIPs, will soon be in every weather office in the country. They'll let forecasters see several layers of data on one screen and help make sense of the information explosion. Tornadoes and all the destructive elements of thunderstorms will always be with us. They'll destroy homes and businesses. Floods will wipe out whole valleys. Downbursts will threaten aircraft. The best we can hope for, at least in the foreseeable future, is warning. Enough advance warning to allow potential victims to become survivors. It's research that will give us the understanding, the equipment, and the communications network to make that warning possible, so those in the path of the storm can take cover and escape its wrath. For the Weather Channel, I'm Dennis Smith.